Okay, it's question 10 this time. Similar type of question to the previous one, where it's asking us which is the most powerful reducing agent. Again, in order to be the most powerful reducing agent, it itself, or the species itself, wants to be oxidized. And so in order to be oxidized, the species has to exist towards the left-hand side of the equation. In order to do that, it has to have the most negative electrode potential in the table. And so in order to be the most powerful reducing agent, like I say, the one with the most negative potential is a zinc 2 plus couple species. And so the most powerful reducing agent is the one which itself wants to be oxidized. And in that case, it is zinc, because that wants to lie towards the left-hand side of its equation because of its negative electrode potential. Now, next question then takes again a little bit of thinking about, because we have to figure out from the table a species which in acidic solution will reduce VO2 plus to VO2 plus. So we have to identify the correct equation. So it's this one. Okay. But will not reduce VO2 plus to V3 plus, which is this equation. Now, what we have to do is the equation we're after looking at is the reduction of that species. So this equation in question has to go towards the right-hand side. So in order for that to go to the right-hand side, any reaction that will go alongside it, the other half cell, has to have a lesser, more negative voltage. So basically that means anything above it in that table. It does not mean anything below it. So it's got nothing to do with chlorine or chloride. So that's not the equation we're looking at. We're looking at anything above the equation in that table, or the other way of looking at it is anything with a lower voltage than plus 1 volts. So that reaction, as I say, is going to go from left to right, from VO2 plus to VO2 plus. That means it's going to react with essentially any of these species here, because these ones are all going to want to go backwards. Okay, so we've got it down to zinc V2 plus, this sulfonate thing, the V3 plus or iron 2 plus. But there's a caveat to the question. It says will not reduce VO2 plus. So in order for this reaction to proceed in the forward direction, that must also have a couple with anything higher than it in the table. So what we're looking at now is essentially the odd one out, and this iron 2 plus couple here is the odd one out. Now it's fairly obviously standing between the two anyway, but in order for the VO2 plus species here to react with iron 2 plus here, this will go forwards, this will go backwards. That's fine. What we have to make sure is that the VO2 plus equation above it isn't then sufficiently strong enough to make that reaction go back the other way, and the voltages don't allow it to do. So in order for this one to be right, the species which will reduce that substance but won't reduce that substance is the iron 2 plus species. Okay, now we've already kind of alluded to this one, but for the final question, a species which in acidic solution will oxidize this one. So this now is ultimately going to take this the other way around. So I'll get rid of all this out of the way. But what we've got this time is the equation now going backwards. So we've now got to go backwards. So what we have is, if this one is going to be going backwards, it must have been forced backwards by a reaction which has proceeded in the forwards direction by a more positive voltage. The substance with the more positive voltage is chlorine.